2021. He has PhD from NIT Rourkela. He has in past being associated with Honeywell Technology Solution Labs, Bangalore. Worked as assistant professor at VIT University and IIIT DM Kanchipuram. He has co-authored over 23 plus international journal and conference articles. Our Internet of Things, machine-to-machine communication, cybersecurity issues in IoT and cloud, wireless sensor networks, software-defined networks, and cyber-physical systems. He's IA, ENG, and IEEE. Today, he will be taking the session on data link layer of, and he will also be discussing about the challenges on different layers in Internet of Things. And also he'll be taking a brief introduction about the architecture of Internet of Things. So without any delay, sir, I request you to kindly take over from here.
Yeah, thank you, ma'am, for giving me this opportunity. So first of all, I would like to thank all the coordinators for giving me this opportunity to speak about an IoT. And I welcome all the participants from the different centers. They are welcome to this event. So I'll be going to share my screen. So my screen is visible to everyone.
Yes, sir.
Yeah, okay. So I welcome to all of you for the today's session on IoT system design challenges. So in this particular session, I'll be briefly introduce the various type of technologies that are available. Either you can talk about the physical design or a network design or a logical design. And at the end of this session, I'll be showing you some of the use cases which we have implemented in our research. So let's quickly look at into the what is IoT basically and what are the challenges associated with the design of an IoT system. So first, let me introduce you what is IoT. So this is just a buzzword. So IoT is not just a newer thing. It's already been there from the long time, but with the different names, they will be known. Like we were known about the pervasive computing, unambiguous computing. So these are the few names that were there from the long back. IoT is just a new addition of the name, just creating a buzz in the market. So IoT is basically collections of different technologies which can offer us interoperability between the different devices, different types of communicating nodes in the network. So basically, it's the core part of an IoT is an embedded system where we will have sensors and actuators connected. And at the outer end, we will have the web application interfaces or software interfaces through which we can analyze the data, we can control the remote access over the network, we can create a complete systems with the set of IoT sensors and actuators. So basically, it is a network of embedded sensors and actuators, which forms a smart applications. So network of sensors and actuators operated basically with certain constraints. So when we talk about Internet of Things, things may consider various kind of devices which can have a communications capability over the internet. So those devices which can communicate over the internet, they can also be uniquely identified in a network with their IP addresses, but it is not always be the concept will be applicable for all kind of devices which can only communicate with internet. There are some networks which are basically operated in a physical layer and data link layer, which will not have any kind of IP set. In those cases, we will also have a certain mechanisms to establish a communication over such networks. The wireless sensor network is one of the example where we have a homogeneous kind of devices. And to connect them and remotely access them, we must require certain gateways. So IoT is a term which is basically representing that everything we can connect it with internet. But if you can start implementing some of the IoT applications, you will see there are a lot of difficulties in terms of interoperability. If you can see, some protocol may not support another protocol. Some sensor devices may have different data formats. And to process those such data, we require a unified format. So such challenges can be addressed in Internet of Things by making a different set of gateways. So IoT, when you start making some applications, you have to figure out certain ways to communicate between a different interfaces, a different device set. So IoT is a collections of gateways. If you can very good familiar with the gateways, like embedded systems, sensors and actuators can be embedded over an embedded device. But how we can connect them with the internet, there is another set of gateways that we must require. After connecting with the internet, we have to process our data over the cloud systems. There also we require certain gateways. So gateways are important in order to facilitate the Internet of Things in a broader sense, when we have a different type of devices connected in a network and they all are exchanging the data between each other. So usually Internet of Things devices are not like a computer network kind of devices. We were having a very constrained devices. They can operate with certain limitations. Like most of the IoT devices are operated with battery powered. So they have a limited amount of power sources. They have a very less network speed, so they cannot process data faster. They cannot send the data faster. Computing resources side, we will also have a microcontroller and microprocessor based embedded systems, which can process according to their clock speed. So there are also, we have a limitation in terms of processing a high amount of data. If we are working with certain AI or ML based applications, we have to look at the physical device. What are the devices are available which can help us to process a bigger amount of data or a big data kind of. So we have various options in a commercial market. We either can go with a normal embedded systems, standalone embedded systems, or network oriented embedded systems. So various such physical devices are available. I'll be going to introduce you about the type of devices, how you can choose a right device for your applications, what we have to look into the device in terms of requirements. And beside that, the cost and other constraints based on its requirements. So we will be going to look at the all aspects related to the physical device or a physical design of a network. So with this figure, you can understand basically the core of IoT development is an embedded system. So it's an interdisciplinary kind of area where you have to be good in embedded systems. If you are knowing very well about the sensors, actuators, how to connect with the embedded systems, how to control them. After that, you have to look at into the network side. So network knowledge is also very, very important in order to control the device from the remote locations, in order to transfer your data from one device to another device or to the cloud servers where you have a virtualizations to process your data. So there are various type of challenges that we must face in every step. Either we can talk about the embedded system based edge network or computer or our network of devices where we have a different set of networks where we process our data. That also be are important facts depending on what type of data you have. Either it is a time sensitive data, non-time sensitive data. So every applications have different demands. So how basically IoT development stack is introduced? If you can look at, there are various type of architectures are given. Some of them are 4-layer architectures, some of them are 5-layer architectures, and some of them are 7-layer architectures. So there are no limit of the development stack in the IoT, because every year a new particular gateway or new particular functionalities are added into the whole development stack. So sometime you will see some textbooks, there are only 4 layers are important for an IoT development. But in some cases, you may observe there are many more other layers. So functionality wise, if you can look at, it is mostly correlated with the OSI reference model that we see in our network, where we have a layering structure. Similar way, IoT is also having a layering structures where you have a different set of rules, different set of protocols operated in the every part of the layer. If you can look at this IoT development stack, you will see hardwares. Usually hardware is the part where you will have the certain kind of sensing and actuations requirements. In your particular applications, if you are trying to create some hardware-based automations in certain field, then you can obviously go with the hardware set of devices. Choose according to your requirements. So there are certain specific requirements that you must understand in terms of embedded system. What are the important ports are important for any kind of sensor connectivity, what type of sensors you want to connect, what port are required for such type of connections, how much processing do you need, whether you want to apply all functionality in the same device or some part of the functionality you want to program and some part of them functionality you keep it as a hardware functionalities. So there are various such devices are available designed by various type of companies. You can either go with the ESP, Philips, STM, ARM processors. Beside that, you have other like Raspberry Pi boards or BeagleBone black boards, likewise Jetson boards. So many different IoT boards are available, which you can integrate at the edge of the network. So you can perform a various type of automations in your applications. Beside that, device SDKs are also available. If you can look at the various cloud service providers, they are also providing their device SDK. If you can go to the Amazon Web Services, you will get free RTOS operating systems, which can directly communicate with the Amazon Web Servers. So whatever sensing that you are applying over your applications, like you are sensing some temperature or some other parameters, you can directly send it to the Amazon Web Services cloud. So these firmwares you can directly download from the cloud service provider and embed with your embedded systems. Similar to that, connectivity is an important part of this. Since you have not a single device for monitoring the things, you may have multiple devices in a network, and collective data you are interested to process or interested to receive from every individual devices. So you require certain connectivity standards. So there are many such devices which can be operated in a personal area network or in a local area network or in a wide area networks. So various device standards are there. I'll be going to talk about that. So depending on your requirement, how much area you want to cover and how many devices you want to keep as a coordinator or a gateway or as a sensing node. Various protocols are there in between that. Once you collect the data, you transfer your data to the cloud servers. So to facilitate those data transmissions, you have various communication models. So MQTT, HTTP, REST API, so many different protocol standards are there, which can take your device sensing data to the cloud servers or to your storage requirement where you want to save this data, either in the local network or in the public network. Data storage standards also there. So what's basic requirements you have in order to save your data? So various such databases are available, which you can use it. So different requirements set. According to that, you can have different data storage. If you want to process every information at the edge of the network, basically at the device itself, if you want to process every information and take some decisions there itself. In that case, you have a certain database within a size of 1 MB or less than 1 MB. Such databases, you can also store it into the device itself, rather than depending on the cloud's processing or a fog computing platform where you can process your data. So depending on how much data you have and how much data you want to process, what type of analysis you want to perform over the data, depending on that, you have a different type of data storage. So data visualization and analysis are basically a web design framework. If you are interested to create certain dashboard to visualize every data, what decisions, what predictions you want to make, everything you can design it with the web front. So various such platforms are available through which you can design your dashboards. Either you can go with a Django production server or a Flask web server for the initial start, or there are Ajax or React. So many different platforms are there where you can visualize your data coming from your sensor networks. Okay, and you are processing some data and predicting certain outcomes that can also be visualized over the data visualization part. Even you can generate some alert and messages in order to create a kind of control system where you have only take certain alert systems, like certain temperature is going beyond a threshold, you should alert the system. Or some of the historical analysis over the data you want to perform. Suppose you want to take some data, process it, find out certain features out of it, and then you train certain models. So when you receive some online data, you can take some predictive analysis over it. And later on, you can make certain decisions over it. Okay, so feedback control systems or open loop control systems, depending on your requirements, you can implement such a IoT application. So what are the technology roadmap that is basically helping us to make this interdisciplinary communication between a type of technologies? So basically, when you go for any IoT application design, you must think of first what should be my physical design technologies, what kind of technologies I should adapt in order to establish a certain type of application requirements. So first you have to imagine what applications you have targeted. Related to that, what systems are available, what kind of resources you have, and with those limitations, you can choose an appropriate controller, appropriate device, appropriate power resources, and then you can move on to the network side. So network side, there are many important aspects that you must cover up. Let's say if you are creating 1,000 node to sense the environmental pollutions or temperatures. So 1,000 device, when you place it in a network, whether your gateway is capable to receive from all 1,000 devices, or you have to segregate your network, or you have to revise your topology. So various kind of factors are important in order to establish and plan a network design for an IoT systems. Okay. So within that, we will have a various type of solutions that can address most of such problems. So in physical design, certain challenges are there, which we can address it with various type of technologies that are available today. Network design, there are many such challenges which can also be addressed with the available technologies. And in logical design technologies, we will also discuss about what type of semantic web technologies helping us to gather the informations which is available on World Wide Web, and to make use of that data for predictive analysis or for alerting something. So various such examples are there which works on the semantic web technologies in IoT. So these are the technologies, if you can look at the actuation, sensing, processing, communications, they are mutually comes together and forming this technology roadmap for development of an IoT. So these days we have a better integrations between the sensors, between the actuators, between the processing and communication. Why we have not imagined such type of integrations in early days? Because internet was not so much mature during that time. We were having a limited set of devices with certain capabilities. They cannot be communicating to a longer distances. But these days, devices are cheaper. They are coming with a various type of interfaces to establish communications, either in the private network to the public network. So such technologies are evolved over a period of time and gave us the options for establishing such kind of mutual integrations to each other. So let's discuss about what is physical design challenges of an IoT. If you are interested to establish a physical network, let's say if you are making a certain medical device in order to sense your body vitals. So you are looking at certain device which can basically process such data. So first you figure out what sensors are important in order to create such kind of medical devices, and what type of processing you are going to establish, what type of communications you have to have between the sensors and the controller. So basically, as we know, IoT devices are constrained in terms of they are operated at very low power, they have very low duty cycle, very low memory footprints, so you cannot store a much amount of data in a device. You even can't process a much amount of data. So there are certain limitations depending on how much memory is available with your controller. You can process that much amount of data. Besides that, they can easily be hacked or tampered. Basically, physical devices are not come with a different set of protocols that we see normally in our computer systems. We have various encrypted algorithm, RSA algorithm. Such algorithm we cannot run inside a physical device with certain constraints. So there are limitations of security. So there are a lot of scope in the security domain. If anyone interested to establish some lightweight encryptions, lightweight security standards, protocols, this is the open area where researchers or many students can work around to create a lightweight system for establishing a security between a constrained devices. Mostly such devices are operated in batteries and energy harvesting. So you also have to look upon the options, how you can basically operate such device in certain constraints. Therefore, it is very, very important that you must have a knowledge about hardware and software co-design. Until you will not have such knowledge, you cannot establish a complete system requirement with certain constraints. So there are various challenges that you may face during a physical design of an IoT, usually constrained data processing methods. So when you collect some data from the sensor, you have to basically process such data, bring the format of the data in order to process it correctly. So you have to first sense the data, align the proper order of the data, then you have to identify the features from the data, and then you can process such data. So constrained data processing, there are many such difficulties that we cannot address with the physical devices. So we have just migrated towards the cloud computing and other high power system which can process our data. So sometimes we are using a centralized processing. Sometimes we are doing a distributed processing. Okay, so there are many such options through which we can handle the data processing at the edge of the network. So these days, smart watches are very common. These are a very good example of the edge computing, because most of the processing smart watches do itself without sending the data at the cloud server for processing and finding out what is your blood pressure, what is your other important factors. that will give you the healthy details about yourself. So such processing these days are possible at the edge of the network. So when I tell about the edge of the network, means the physical devices which operate at the bottom of the network. So whenever you imagine any IoT applications, you have a set of devices. So such set of devices basically operated in the edge computing paradigm. So I'll discuss about what is edge computing, basically what set of devices operated, what set of solutions that edge computing paradigm offers in order to solve most of the problems that we face in a physical design of an IoT. Another base challenge that we observe, like high latency, because the data that we process or data that we receive from the different interfaces may not come at the same rate. If you can look at the embedded system perspective, there are various interfaces that you see on embedded system. Some of them are like analog interfaces, digital interfaces, UART communication interface, SPI communication interface, I2C, CAN protocol. So these are the interfaces where you will be going to connect different type of sensors. Okay, when you connect such sensors, you will see a specific protocol operate in such type of interfaces. If I talk about UART communication protocol, it basically a asynchronous mode of communications between a sensor and the controller. But when I talk about SPI and I2C, these two communication interfaces over the embedded systems are synchronous. So they are basically operating at a higher speed as compared to the asynchronous mode of communications. So similar to that, there are other interfaces which will also operate with a different speed. The reason of that, we will not accumulate all the data together at the same rate. So such constraints are there, which basically impose a higher latencies for receiving a data and transmitting a data in a real time. So some application demands a real time where we cannot have such minimization of latency. Beside that, a low connection reliability, if we can completely depend our processing over the cloud servers or the high-end systems, centralized systems, we may introduce certain delays. We may also expect certain disconnections or low connection reliability. So internet is not all the time available. Sometimes it may fluctuate. Sometimes heavy traffic is there. So we cannot optimize the public network. We can optimize private network. So how we can do all our computations, all our communications within a private network rather than going to the public network. Okay, so there are certain cases where edge computing can solve such problems. Process our data on the fog nodes, which is basically a replica of a cloud, which basically operate within a private network rather than we are depending on the public networks. Data management is another important challenge that we face. Usually the memory inside embedded systems or controllers in a few KBs, sometime in MB, sometime if we can see sometime in 1 GB or 2 GB kind of storage we may get in our controllers. We cannot process a big amount of data. So we must have some solutions in order to manage our data within a device. Security and privacy is also another major concerns because physical devices are easy to be tampered. Physical tampering is much more easier with the IoT devices. We can directly go to the device, we can plug it with UART communications, and we can extract most of the data from the device. Such physical tampering are these days are much possible with the physical devices. So how we can prevent such tampering or such data that we cannot basically protecting within a device with the limitations, since we don't have enough computational capabilities to run a normal encryption algorithms to safeguard our data. or to prevent our data. So we should have certain lightweight encryption techniques, lightweight security policies, which can prevent our physical devices from the external attacks or cyber attacks. If we can expose any IoT device in a public network, it is highly vulnerable. Cases where the device can protect himself, because device is completely exposed in the network. Anyone can access such devices with a limited privileges, or they can escalate the privileges by introducing a various type of attacks. So we are not doing any penetration test before the deployment of our physical devices. So lightweight analytics, that also be a kind of challenges that we cannot perform with existing controllers, which has the limitations of processing such a huge data, because analytics basically derived from a certain amount of data. If we will not have enough amount of data, we cannot derive certain analytics over the data. So let's say if you are interested to design some of the IoT systems, there are certain available commercial options are available, which you can choose according to your requirement. If your processing is big enough, then you can go with the AI version boards are available. If you are intermediate processings, then you can have various options. Raspberry Pi is there, BeagleBone Black is there. But how you can choose your physical platform? What is basic requirement that you must consider while selecting a physical platform? You should look at what are the GPIO ports are available. Whether you are interested in analog or digital, some boards will not come with any analog ports. And most of the physical entities that we want to measure are analog in nature. So either analog is important for you or not. Depending on that, you can also select a certain board. So these are microprocessor based embedded systems. Some of them are microcontroller based embedded systems. Microcontroller based systems are standalone. They can just do a few dedicated tasks. But if you can look at the BeagleBone Black, Raspberry Pi, MIPS Creator, CI20, these are like a single board computers. They are computers. If you are interested to use them as a computer, they are only a 3,000, 4,000 computer. You can connect USB, keyboard, mouse, and anything you can connect it. You can run an operating system inside such boards. And you can process in a similar way as your computer process the data. Only the limitation is that the processing capabilities, the peripherals that you will see on your computer systems, there are certain limitations are there. So in this, if you can choose any of the board, you can look at the speed requirements. If you want to process higher speed of data, you can go with the processor speed. You can check out the processor. I suggest most of the embedded boards, like they have external memory to be connected, like SD cards, through which you can load the program inside the Raspberry Pi. BeagleBone Black board comes with a flash EMC, so you need not to connect any external memory, so that your speed of the systems going to get reduced. So Raspberry Pi board is not much faster compared to the BeagleBone Black. So depending on your choice, you can select what peripherals you want, to what type of interfaces you want to connect your physical sensors, various type of processing, various type of data you want to process. According to that, you can select. If you are interested in AI or machine learning kind of processing in IoT, then there are various such boards are also available, like Google Coral board is there, which has a TensorFlow processing unit. So you can process your data within TensorFlow library. Same way, BeagleBone AI board is there, which can also process a big amount of data. Let's say if you are working with the image processing, speech processing, such a huge processing where you have to perform over the device itself rather than going to the cloud and process your data and get the written result. That will introduce a lot of delays. So if you want to make any responsive systems, you can either go with the AI boards if you have a lot more processing in your automations or in your IoT applications. So physical design, most of the challenges you can address it with the edge computing paradigm, where you can get a lot of important features which you can enable it at the edge of the network. So most of the problems that you will see, basically data processing, beside that security, and as well as your latencies and throughput, such problems you can address it with edge computing. You can do a virtualization in your physical devices. With the virtualizations, you can enable a lot of the additional features that you can add it into your devices. Basically, it can perform the various complex processing with a limited resources. So constrained data processing, like if you are processing some data which is having a different formats. So first of all, you have to bring the complete format into a certain processable format. So there are data serialization methods are there. Various tools are there which can help you to basically do the constrained data processing. So like you have a Kafka, Tablib, and Pandas are there which can do the data serializations. If you are extracting some data from the sensor, you may not get the same set of data. You may get sometime a binary data, ASCII data. Such data, you cannot process it with your analytics. You may require a certain specific format which can be processable. So data serialization is a method which will basically translating your data into a byte stream, and that you can format it with XML, JSON, BASIN, and YAML. So these are the formats you can use for data serializations at your physical devices. So Tablib, Kafka, and Pandas, lot many libraries are there which can help you to translate your data into a processable format. Edge computing can also offers you the low latencies. If you want to process every information at the edge of the device, you choose according to your requirement so that you can process every requirement at the edge of the device, your physical device, rather moving towards the high computational platforms, centralized servers or cloud servers. So edge computing, basically it's a kind of distributed computing which you can perform within a same network, within a same device. High connection reliability you can offer with the edge computing because everything is operated in the private networks within your certain communication range, so that you can also optimize as per your requirements. You need not to optimize the private network because private network is not under our control. Public network is not in our control. There are a lot many certain delays that can be introduced because of the old technologies, routers, many routes are there. But in the private network, we can optimize our communications, our networks between the devices. So high reliabilities are possible with edge computing. So most of certain designs these days are focusing towards the edge computing. In IoT domain itself, most of the communication, most of the automations are restricted to the edge computing. And there are various type of such computings are introduced in today's scenario. If you can look at, if you are interested to send some data into the public network also, there are the division or classifications of data. If time sensitive processing that you want to perform, like an alert you want to generate, or some schedule that you have maintained in a system, and that schedule you wanted to operate in a real time. Such cases, edge computings are better. If you are not interested to take any responsive actions against your processing, in that case, you can simply rely on the cloud. Even though some data is lost, you will not get any lack in performance or lack in quality of services. Such non-sensitive, time-dependent or non-time sensitive data, you can directly send it over the cloud. So depending on your requirement, you should switch your computing requirements to the devices that they are operated in the network. Data management, you can also do it on an edge of the devices. These days, we have a very small databases that you can run it in a size of 1 MB. So like Berkeley DB, Label DB, Object Box, RealM, Redis, Rox DB, these are the databases that you can operate within the embedded devices. You need not to go with the MySQL, such heavyweight databases, third-party databases. These third-party databases are specifically designed for the embedded devices. If you want to structure your data inside a memory, you can go with these databases. Besides that, we can also achieve most of our challenges that we have seen in physical design with the virtualization. So virtualization basically helping us to create a division in the resources. So we have two different type of virtualization: hypervisor-based virtualization. Basically, hypervised virtualization is not very promising for the device with limited resources. But container-based virtualizations definitely helping to process a big amount of data with a different type of algorithm. Let's say you want to process your data with different type of machine learning algorithm. You can go with the container-based virtualizations. It definitely gives you the added advantage over hypervisor-based virtualization. So usually hypervisor virtualizations divide your resources, and individual resources are separated from the other resources. So you can run a guest operating system in every resources. But in container-based virtualization, it's a virtualization enabled at the OS level. So you need not to partition the entire hardware resources. You can simply execute in a scheduled manner. So container-based virtualizations are better in order to process your data at the edge of the device. If you don't have a sufficient computational resources at the end of the server, or where you don't want to process your data because your data is time sensitive, your data needs to be processed fast, your data need to be responsive after a certain analysis. So you all can do with edge devices. Just the requirement is to select the device according to your requirements. So there are many such options in IoT domain. You will see a large varieties of devices are there these days. Now let's come to the network design of an IoT. So physical design, once you figure out what type of devices you require for your certain applications and what set of sensors you want to connect with your controller, what type of processing you want to perform in your controller, every processing you want to process at the edge of the node, or partial want to process and partial data you wanted to transfer to the network. So in the network design, basically, if you can look at Internet of Things, exponentially popular catchphrase over the last few years. And by 50 billion devices by 2020 to 1 trillion by 2025, these are the expected projections for the number of devices get connected into the network. So when these many devices are operating in a network, you can imagine how much IP addresses do we need. Currently, we are operating with IPv version 4. We have a IP size of 32-bit, which cannot accommodate these many devices. So we should require a certain kind of IP change. So these days, IPv version 6 is most popular, which gives 128-bit size of an IP address. So we can accommodate more and more devices in the network with a unique identity. So as I said, there are also certain challenges in the network which needs to be addressed. Since every device cannot be get interfaced in the internet, some IoT devices will have a network interface card, so they can be uniquely identified in a network with an IP address. But when we talk about a sensor network, where homogeneous sensors are deployed for sensing certain event, such device, how we can control if they are operated with the personal area network communications, they don't have a IP set. So if you can look around these days, ZigBee, which was operated earlier in the personal area network. These days, a newer ZigBee is also available. ZigBee neighboring area network. This device is operated with IPv version 6 protocol standards. So you can, these days, you can also address the ZigBee in a network with an IP address. Okay, so Bluetooth BLE devices are also nowadays coming with a certain IP set, so you can connect them in a network and get the IP for that. Some devices which cannot be get connected in the network, they can be connected through an interface, basically a gateway, which can facilitate certain communication between the devices. So non-IP devices can also get connected in the IP network with the help of certain gateways. So wherever these interoperability challenges are there, we must require a certain gateway. So what are the challenges that we may face when we look at the network design of an IoT? So first challenge is unique identity. We may not have every device with certain connectivity of internet. But these days we are replacing the personal area network devices with an IP support. So these days ZigBee, Bluetooth, or wireless HART, Z-Wave, these are the devices can also get an IP addresses in a network. Dynamic and self-adaptability. So when we talk about an IoT, IoT is not just limited to our network. Let's say we are designing a network for our control. Yeah, I have designed a network for monitoring the environmental parameters. So I can perceive some of the information from the other informational networks. If you can look at, I have other devices also connected in the internet. When I tell you about the 50 billion devices by 2020, 1 trillion devices by 2025, these all devices are exchanging some data. So if I am having a one set of device which can monitor one parameter, and I need a one more parameter in order to give a correct predictions for the particular event, then I can search such particular data in the informational network in the internet, which device is going to provide me such feedback or such data. Okay, so that is what the interconnectivity should be there between the devices. Devices himself needs to perceive this informations from the external devices, which may not be available in the same network, but they can be available on the internet. Okay, so like a camera system, camera can capture a certain image. So it may be located in Europe, and I am sitting in India and wanted to confirm the identity of a person. When camera captures an image, then I can receive that image through a global network and identify its identity from my global database. So such kind of utility is must. So dynamic and self-adaptability, I'll give you an example related to the dynamic and self-adaptability. Why devices should be self-adaptive, self-dynamic. Self-configuring is also an important part of the network design. Besides that, we have an interoperability challenges, which also needs to be addressed properly. Otherwise, we will not connect every device into the network. So this is very, very important. We must consider interoperability. Integrated into informational networks, so every device needs to get connected with the informational networks. Informational network is nothing but internet or World Wide Web data. So we can also get some information from the World Wide Web. If you can see a good example of the integration of the devices with the informational network, then Google Assistant is there. Likewise, Alexa is there, which can connect, and then you have Watson computer is there. So many AI-based systems which can gather the data from the internet and provided you as a organized manner. But if you can look at, we still not have such kind of systems, proper systems. Google Assistants only work for a Google products because they have a proper semantic web technologies to arrange the data for a machine understandable. So there are certain limitations. Data cannot be get extracted from anonymous resource sources. They must be arranged in a certain order. So that will be an important part of the integrations to informational network in order to gather the data from different resources. So fault tolerant is another important challenge that we are facing these days. If devices are get connected, some of the devices may not work over a time. Some data may not get correct data. Sometimes servers are not operating. So what mechanisms we have in order to manage the fault? Besides that, latency, throughput, scalability, security, and what type of gateways we must require in order to design a network of the embedded devices or network of the IoT devices. So if you can look at the device options for establishing a network, so we will not just have a wired communications. We may have some wireless communications also. So according to these, we have various type of fixed and short range communications standards, certain devices which can operate in a fixed range and short range. They cannot be operated in the long range communications. Long range, we will also have a LoRaWAN, Sigfox, NB, IoT, RPMA, 4G, LTE-M, EC, GSM, which works on the third generation cellular communications. 5G is the another important addition. Okay, so what are these devices? So as we said, Internet of Things. So in various type of things may have a different communication devices. In order to connect them with internet, we must require certain gateways. If device is not IP based, device with IP support, they can directly get connected into the internet. So every devices will have a specific standard of communications. So all such devices are the part of the IoT. Some of them are getting connected directly with an IP. Some of them are non-IP. So if you can look at personal area network devices, the non-IP based network devices, we have a ZigBee. So ZigBee, we can connect it for a non-IP based communication networks. So if you are creating a network with a ZigBee based devices, you can have a unique identity as a ID. So ZigBee is basically using IEEE 802.15.4 IEEE standard. According to this standard, we will not have any IP for the ZigBee. We have a PAN ID, personal area network ID. We have a device ID. With that, we can identify a particular ZigBee in a network. But if we want to communicate with such ZigBee from the remote locations with the help of a network, we must send our packet at first to the network interface, where this network interface getting connected with a gateway. So gateway for the ZigBee based network can only establish a communication with the ZigBee devices. So the gateway will have an address of every ZigBee. If we want to talk to the particular ZigBee, we have to translate our IP packets to the IEEE standard format packet to communicate with the specific devices. So if you are forming a network of your communications with wireless sensor networks of homogeneous communication devices, you have to have one gateway in between the non-IP to an IP. That will basically a kind of gateway. Bluetooth also there, Z-Wave, wireless HART. These are the non-IP based device standards. They are also used. So Z-Wave is very popular in US. They are using for their security systems. Wireless HART is another important device which operated in the industries for monitoring the chemical plants. Various type of gaseous leaks are there, which they can be monitored with the wireless HART standard devices. So they have a specific set of format, specific operating characteristics. So Z-Wave cannot operate more than 3 hops. So the communication between the gateway and the device, Z-Wave device, let's say in a network you have five to 6 devices. If the end device cannot directly communicate with the gateway, it can transfer its data to multi-hop communication. So multi-hop limitation is also there in this standard because it has to maintain the latency and the throughput. So Z-Wave protocol says that if you cannot directly communicate with the gateway, you can take the multi-hop communications, maximum 2 or 3 intermediate nodes you can use to carry forward your data till gateway. So these standards are fixed for this fixed set of devices. Same way wireless HERT is there, Bluetooth is there, ZigBee is there. They are non-IP based networks, which we can also create in an IoT domain, and we can establish communications with the help of a gateway. Now, IP-based personal area networks. So within this, if you can look at 6LoWPAN. 6LoWPAN is what? These days, personal area network devices are also coming with an IPv version 6 protocol standard. So if you can look at ISA, Industrial System for Automations, this is one specific set of protocol standard. So it is not a device. So if you are interested to operate this particular standard, which is decided by the Industrial Automations under 8.11a, you can download its library from the internet, install it into the Raspberry Pi board or whichever embedded board you have, and you can get all the features associated with this particular standard. So it is using 128-bit logical addresses to identify a particular device in the network. Thread is another device which is basically operating in the same standard of the ZigBee. It is capable enough for creating a mesh topology and routing. So thread protocol standard is IEEE, so you can establish your communications with the IEEE standard of 802.15.4. So it is almost similar to a ZigBee protocol stack, but it is IP based. So we can also get an IP associated with this particular device. ZigBee NAN is a neighboring area network. So these devices nowadays are also coming with an IP. So you can connect this device also directly into the network without any problem, and you will get an IP. So unique identity is must for a device in a network. Then only we can say that this device is a uniquely identified in network. Long range technologies are also there, which we can also use for our communication network. Let's say if we want to measure a complete city temperature or pollution standards, we either have a personal area network devices, but if we can plan such network of ZigBee, we required millions of devices to be deployed in an entire city. But there are a certain advantage if we can go with the LoRaWAN. So LoRa gives a 15 to 13 kilometers of communication range. So by keeping only 10 or 20 devices, or let's say 100 devices, you can cover the entire city monitoring, whatever the parameter that you are interested to monitor it. So LoRa is one of the options, which is a long range technology, but it is also non-IP based. So you can only communicate with a very low speed with a LoRa kind of devices. Sigfox is basically not a device. It is a company, French company, which basically designed a protocol for their own devices. So IoT is an area where you can also invent your own device, your own protocol stack, and you can commercialize it into the market. So Sigfox is like a software module, which you can directly go to their website. If you can look at, I've opened this website. This is a Sigfox OG technology. So if you are a developer and interested to develop something, you can directly go and get registered with this. They will give you the installations of Sigfox protocol, which you can install it in your device and you can operate it, your device with their protocols. So Sigfox protocol has certain specific features, like you can only send 100 messages per day. Like in our cellular communications, we will get various packages, like 100 message package you will get. Same way, Sigfox protocol introduced a specific set of protocols for communications. You can have a specific size of data communications. You cannot expand your data communications to anonymous size. So let's say if you interested to communicate with another Sigfox device, you have to have certain KB of format that is only the fixed for every communication within the Sigfox. So Sigfox is basically a protocol stack, which you can also download it and make use of it. Like NB-IoT, so narrowband IoT is basically a cellular communication network. So NB-IoT these days are popular because many companies are these days licensing it with their cellular service providers. So Jio and various Vodafone or various service provider signed a certain deal with the various companies in order to give their license of frequencies for narrowband communication. So these days narrowbands are available. If you can think about Tata Power, basically observing all the meter readings with the help of NB-IoT protocols. So they have just kept a device on the monitor, this electric meter, and they can observe the number of units. According to that, bill generated digitally. So this is what kind of use cases of NB-IoT, and it is very, very popular these days. But what is the concept behind the NB-IoT? So it is basically a division of the channel. Let's say Jio has allotted a certain range of frequencies for its cellular communication, or Airtel has a specific range of frequencies. So licensing of the frequencies they have. So few of the licensing frequencies they reserve for the non-cellular or voice over communications. So data communications or your specific these days applications related to NB-IoT automations, they are segmenting the particular frequency into a sub frequency, smaller frequencies, so that they can accommodate more devices in a specific range of frequencies. So narrowband IoT is basically a cellular communication which works on our cellular network providers, either it's a Airtel or Zigbee. So such devices may basically require a SIM card. You have to insert a SIM card inside a device in order to get registered your device with the service provider. Later on, you can exchange your data with the service provider. So wherever the network availability is there, you can communicate your device data, sensor data via this particular cellular network. RPMA is another protocol standard, as well as it's a device where you can install the RPMA provided protocol standard for your IoT communication. So long range communication, if you want to establish, RPMA is also one of the options through which you can establish a communications. So it is also similar like a Sigfox. Here also you have a specific set of requirements for establishing a communications. If a fixed format of data communication is there, you can directly send your data to a fixed format. LTE-M is basically a 4G communication module. So if you are interested to make use of cellular communications, so make use of LTE-M modem. So LTE-M modem is basically a 4G modem that is there in our mobile also for receiving the data packets. So our mobile phone have a LTE-M modem. We are able to access the 4G communication network using cellular service provider. So this modem is available in the commercial market. You have to insert a SIM card and you can start getting the data packet communication network with your service provider, cellular service provider. ECGSM is basically operated in a 3G communication. LTE-M is 4G communications, and ECGSM is a 3G communication. Third generation cellular communication. So 3G was there, before that 2G was there. Likewise, ECGSM is used for low data packet communication. If you are not interested to send a big amount of data, you can go with the ECGSM modems. And 5G is still not yet introduced, but most other countries will have this. Once the 5G gets introduced in the market, then we may solve most of our problem with the network bandwidth and the channel availability. So 5G offers the infinite channel possibilities. So we will not face any kind of message that we normally see in our 4G communication. When network is busy, then we will not able to send our connection is not established between the call. Okay, so 5G offers a lot of advantages over the latency, throughput, such problems. We can simply resolve it. We will get available all the time the channel for communications. So if we want to transfer our data at any point of time, we can get certain data communication. So 5G is basically operating at a higher frequency, and LoRa is operating at very low frequency. So 5G offers the fast communications with very low latency, but LoRa will have a very low frequency, so we can only transfer data at a low rate. But the added advantage is that LoRa is long range technology. 5G can communicate to a smaller distance because of higher frequency, cannot travel for a longer distances. Since 5G is a network, so we can relay our data one device to another device. So 5G is definitely a game changing in IoT. Once it get introduced, we will be going to have a better communication network. Here are the carrier frequencies. If you can observe, if you are interested to make use of the long range technologies, they are basically operated with a certain frequency range. So LTE, LTE Cat-M, NB-IoT, CGSM are licensed cellular communications. Licensed means you need to pay for this. You cannot use LTE 4G modem devices connected with your IoT devices to relay your data over the internet. You have to pay to a service provider, either it is a 4G, Jio or Airtel, whoever. So these licensed frequency, we cannot use it free of cost. But unlicensed frequencies we will have like 2.4 gigahertz, INGU RPM is there. Sub 1 gigahertz unlicensed frequency LoRa can use, weightless and Sigfox. They are operating in unlicensed frequency. They are available for a civilian use. We can use it without any concerns because they are operated within a ISM band. So rate of communications, you can also observe licensed cellular communications offer higher bandwidth as compared to the unlicensed frequency band, because they can offer only KB, kilobytes of data. But megabytes, you can get it with 4G, and 5G, you will get it even more. So range of communications, you can also observe. So Sigfox is basically offers you 50 kilometers in rural area, 10 kilometers in urban area. That is what the range of communications between the two different devices operated at a distant communication networks. So by using a fewer set of Sigfox devices, France covered its entire country with a very limited number of Sigfox. If you can go to the case studies of Sigfox communications, you may get a detail about this. So unique identity is must for an IoT devices. Without any unique identity, you cannot identify a device in a network. You cannot control them. You cannot remotely access them. So the first of the basic requirement is that device should be addressable from any locations. So if you can look at this example, there is a wireless sensor network, which is basically sensing various environmental parameters, but we cannot individually gain access over a device since they are not operated with the logical address. of a public network or a private network. They are operated with the IEEE standard format of addressing. So we must require a gateway which can interface and establish this communication network between the public network and the private network. By this way, you can only achieve this objective. Dynamic and self-adaptability is basically a capability of the system to adapt based on the changing context. Like surveillance camera can adapt their mode based on the weather, it is day or light. Camera could switch from lower resolution to higher resolution. These are the self-adaptive features of the devices. So when you connect a device in a network, you wanted to make it smart. Okay, so these days we are talking about a smart application, smart automation, smart healthcare, or smart cities, kind of different phrases are there. So they are basically driven through a dynamic and self-adaptability concept. So your devices in network should have the dynamic and self-adaptive features. Okay, so camera could switch from low resolution to higher resolution mode. These are the self-adaptive features. How you can have this similar feature in your device when you plan any IoT network, you have seen certain limitations are there. If bandwidth is not higher, in that case, your data communications can be stopped for a certain time, or you can divide your bigger size packet into a smaller size packets. Likewise, you can manage your traffic with a certain bandwidth, which you are getting at night, limited bandwidth, but at the certain time period, you are getting higher bandwidth. These are the self-adaptive features you can bring it into your smarter devices in order to establish a proper communication network in your IoT. Like energy, communications, bandwidth, media access, these are the important dynamic and self-adaptive features. So if you have observed one particular router which you use in your home, how many devices you can connect with the router? So that is depending on the bandwidth, that is depending on the frequencies, how many frequencies, how many channels you have. So if one gateway you are connecting with a 50 devices, but your gateway is capable only to handle the traffic of 25 devices, what you will do for the rest 25 devices? You cannot establish your communication network with that. And one more requirement is there in this network. You must have a 1 MB of bandwidth for each individual device. So when you connect with your gateway, 50 devices, 25 devices can be getting 1 Mbps, but other 25 devices may not get. How you can distribute evenly? That is what the dynamic and self-adaptability that you must have in your device network. So if you are having a 50 devices per gateway, that is what the capability that per gateway can handle it. If you require even more devices to get connected with the same gateway, so you have to compromise with the bandwidth, but you're still able to establish the communication. So you have to look at whether your data must go with the 1 Mbps speed or 0.5 Mbps can also be fine for that. In that case, you can have a gateway. In that case, you can have a self-adaptability mechanism. If you have 2 gateways for 50 devices, you can also share between a particular number of devices per gateway. You can do this whole thing in according to your resource requirements. So dynamic and self-adaptability is related to the type of mechanisms through which you can handle the network requirements when you have a network of devices. So you are monitoring something, water quality, let's say, and you have deployed something around 1,000 sensors. All 1,000 sensors are sending a data to a one-way gateway. But the gateway is not capable to process all the 1,000 sensors data. In that case, you must have certain options in order to manage all 1,000 devices with one particular gateway. Okay, so certain self-configurability is must in order to have this dynamic and self-adaptability in your system. Self-configurability is what So your device, let's say you have a complete device network, 500, 600 device you have planted inside a factory. Let's say glass making factory is there, where you are sensing certain activities, temperature, boiler temperature, pressure, various type of quantities you are measuring with the device. And all of a sudden, some device may not work and you wanted to replace with another device. In that case, your device network should be self-configurable. Whenever new device will added into the network, it get automatically configured into a network. There should not be any manual configurations that this device is now added with this IP address or this particular address. So self-configurability is must in order to have this type of communication network. Just a second. Hello. नहीं मैम मैं घर से ही ले रहा था अभी सेशन तो okay so this is what self configurability is must. When you have a device, a newer device get entered into a network, it get automatically configured into the network, automatically get connected into the network with all the resource requirements by itself. So such kind of requirements are there in the networking. So self-organizing network is one of the technologies that are more prominent for the network design of an IoT, where devices can himself modify their requirements. They can adjust according to the context. If you not have enough bandwidth, they can get reduced their data transmissions. They can do the traffic shaping. They can adjust their resolutions if in terms of camera based systems. So various such modifications the self-organizing network can do by himself. So these features are important in order to establish a proper communications in a network of an IoT. Interoperability. This is a major concern not only to the physical design, it is also in network design as well as in the logical design. Interoperability is basically related to the type of devices you have, type of communication standards you have, what protocol set you have, what type of data exchange you have. So depending on all these aspects, you must have a certain type of gateway. So interoperability is what? It is a mechanisms to interface a different set of standards to a specific set of standard which your network can understand. If I am using a XML format of data for processing, but the data which I am receiving from the external devices, they are sending in a JSON format, then I cannot make appropriate communication interface. I must require a certain mechanisms to serialize the data in my required format. So if you can look at the device standard may have communication protocol mismatch. One device network operated with one standard protocol, another may operate with different. To establish communication, we must require some interface, some gateway, low end to high end. So if some devices operated with very slow rate of communication, but some devices operated with very fast communication standard. In that case, how we can negotiate the communication. This is semantic side, if you can see data format, schema, interfaces. Platform side, if you can see operating systems, data structures, what data structures are used for exchanging a data. Okay, what programming languages are used. So some places we have Python, some places we have JSON, React or Ajax. So various type of programming platforms are used in different IoT networks. In order to have these communications between the device networks, we must require a certain gateway interfaces to have this particular communications. So interoperability is the biggest challenge which needs to be get addressed properly. If you can look at in today's IoT is not specific to a one company. If you can look at Microsoft, they have their Azure platform. they have designed Azure platform for their IoT devices. So Microsoft, if you can approach a Microsoft for certain automation in industry, they will bring their own devices, their own cloud integrations. They will not have a uniform standard of protocols that they can globally use. Okay, so European countries or America or Canada or Indian Asian continent, they may have different licensing or different type of standardizations. But in IoT domain, still no standardization is there. That is the reason we are unable to establish a global communication network. Okay, so there is a lot more opportunities in this domain in order to have this problem to be addressed. That is what interoperability in IoT. Since this is not a platform where we can have a specific standard of protocols, specific standard of communications, specific standard of devices. So interoperability is the biggest challenge which need to be addressed. So from different perspective, you can look at from the device perspective to the protocol perspective to the development programming or platform. You can see there are large difference between the integrations between these networks. Another important challenge is integrated into informational networks. So as I gave an example earlier also, like we have a Google Assistant. Recently, Google has announced the specific features that if you can simply tell something to a Google Assistant, it will arrange for you. But that is kind of the service they are offering with their Google services. So if I need to book an appointment with a doctor, so if doctor is also using a Google Calendar, or so my Google Assistants look at to the doctor Google Calendar, and it will find out which particular slot is available, and that will be allotted as the time slot for my appointment. Kind of features are available, which is basically designed within a certain boundaries. They cannot be freely available to every data sources. So World Wide Web is what we basically an informational network where we have lot of informations, lot of data, lot of daily feeds. So continuously data is getting updated over the web, and we are only selecting the data from the genuine sources. If we can talk about the Alexa, which is also basically extracting a certain set of commands that you say, it will get translated to an NLP, and then it is going to look at into the ontology map where exactly this particular set of informations can be available, and it will extract it and provide it to you. So these are the kind of examples where you can see a certain automations between the device and the informational networks. So we must have certain device which can also get communicating and collecting some of the data. Like very good example, like weather monitoring nodes. If you are putting those weather monitoring nodes in a specific city, they can give you the detail about the specific city environmental or weather monitoring. So they can extract the feed that is provided from the various internet resources. So that feed, it is taking by the device and giving you this set of information. So if you are interested to establish some such kind of informational network with your automation, with your device, you can still have this option. You can collect the data. So IoT doesn't mean that you are only making a communication between a devices and bringing the automations. IoT doesn't mean that. The IoT means you can also establish a communication between the servers that you are available in the World Wide Web domain. You can extract the information, exchange the data, process the data which is available, and brings out certain automations out of it. So there are many such applications which is basically rely on the World Wide Web data. So fault detections and management is another important challenge that needs to be addressed, because we are unable to figure out where exactly the error happened, where exactly the device is not working and responding. Mostly when we talk about the physical devices connected with certain standard of sensors, they may not work over a period of time. Let's say I'm using certain gaseous sensor or water quality monitoring sensors. So such sensors basically require a recalibration over a time. You cannot make use of the certain sensors and you cannot expect a correct reading all the time. There are certain drift in the measurement, which is basically always comes with every devices. For every sensors, if you can look at the data sheet, there is a tolerant limit. Every sensor can tolerate up to certain limit. After that, it will start giving you the falsy reading or incorrect reading. So how we can detect certain reading? Even though if we can detect certain reading, what is the mechanism through which we can remotely access the device, recalibrate it, or we can reprogram it? So these days, very popular OTA platform is there. So over to air is a kind of programming technique. You can remotely program a device without going to physically the locations and programming it. You can remotely program the device through an OTA platform. Or if you have a private network where you have your own gateway, you can still program it remotely. Just you need a identity of the device. What is the identity of the device? You can send your firmware from the remote locations getting uploaded into the program inside the device, and you can recalibrate your all sensors to start getting the correct readings. Okay, so but there are various type of faults that we cannot notice it, or they remain unnoticed. So in wireless sensor network case, if we can talk about, there are two types of faults. They can be observed like behavioral fault and persistent faults. Behavior faults like hard fault and soft faults are more prominent. So sensor module exhibit damage in interior state and not able to communicate with each other. So such communication network, let's say you have keeping one node in a network, which is going to sense temperature and providing it to the gateway where the all decisions is going to be made. So temperature is one of the quantity which is observed. Another is a precipitation, another is a humidity. Every device is going to act according to their requirement. But if some devices are not at all responding and giving any sense data, then this is a hardware fault which we cannot resolve it. In that case, we may simply isolate this device from the network. Same way, software faults are there. So sensor module is active state during exchange of incorrect outcomes. So software faults may occur when sensor requires a recalibration or its life expectancies get over. So it is start producing certain incorrect measurements. So analyzing an incorrect measurement of data, you may get always incorrect predictions or incorrect outcomes. So this is what the detection is must in order to get a proper automations or proper analysis of your data. Persistent faults are basically divided in three different parts. One is called permanent, intermediate, and transient. So permanent faults are basically comes with a fault. Let's say you have purchased one sensor and you are assuming that sensor is perfect. You have connected with the device and start sensing data. But data that is given by the device is not correct because it is internally faulty. Such type of fault detection is very, very difficult. So permanent faults are factory made faults. So we cannot do it anything for that, but we have to find out the mechanism how we can deal with certain error if that is coming with a factory made error. Intermediate errors are like sensor module faulty behavior change at a regular time intervals. So let's say for 1 week data was correct. For another week start changing the data. Data has a very long gap. Let's say temperature in a 1 day, if we are measuring and we are observing the temperature change in 1 degree, 2 degree, 3 degree from morning to evening. And the next day when we are observing the degree was 10 degree change. So these are the intermediate fault. For a one particular time instance, they may come. but later on they can go. Okay, so intermediate fault detection is much easier, but transient fault is even more difficult to detect, which we basically observe for a very tiny interval of time. So such fault can also introduce a false predictions or false alarm in your automations or in your design. So we need regular mechanisms to keep on monitoring the sensors data, whether they are performing correctly, they are producing correct results, or they need a requirement to analyze over time, or recalibration or calibration is must. So fault detection is one of the important area where most of the researchers are targeting, and this is what a very difficult part of the automations industries. That is the reason still industrial 4.0 revolution is lagging. The reason is that we cannot completely depend on the automation. There should be a certain partial portion that can be manually operated. So certain challenges are there which needs to be get addressed on time in order to have proper mechanism. So fault detection is the biggest challenge which you can take up as an opportunity to do some research and find out some mechanisms to deal with it. Latency. So in network, sometimes we required data should be responsive, real time. In that case, we cannot compromise with the latency. So we cannot go directly to the cloud server. We can do our processing at the fog server or a fog nodes. What is fog node basically? So fog node is basically a cloud features we are bringing at the near to the edge of the network. So our edge of the network devices are connected with a gateway. At the gateway itself, we can bring it our cloud features so that we can process our data there itself, take up our decisions in a minimal time in latencies. So latency is what important factors that we must consider in our network design if we are making any responsive systems which will give an alert for a certain incident. So IoT devices, let's say you are planted in an industry or in a certain factory, and suddenly a fire hazard happened or certain gaseous leak happened. So your system should not depend on the cloud processing, because the cloud will process actually the gas leak has happened or not. And when it will detect it, it will send it back to the system. So in that case, we cannot reliably depend on the cloud, because cloud system operates in the private network, in a public network. Public network may have a lot more problem because the delay that can be introduced during the downtime of the network due to the processing delay at the cloud, certain network connectivity issues. So certain time sensitive processing we must do at the edge of the network or at the fog node, which is also operated in the same private network, in order to avoid certain time sensitive responsive actions. So how to resolve latency issues? We can implement a sophisticated traffic shaping algorithms. So let's say if you want responsive mechanisms and data requirement that you want to send is big enough. But when you have available bandwidth, you can transmit a bigger chunk of data. When you have a smaller bandwidth limitations there, you can send a smaller chunk of data. Or you can have lightweight routing algorithms. So like computer network routing algorithms are not sufficient in order to have this particular data communication. We need to invent certain new kind of routing mechanisms. Okay, so minimize these latencies are very, very important. So here I have gave one example, like if there are industries or some nodes are there with this particular gateway, and another network we have one more gateway. So if one gateway is failed, then data that is generated from this network should not get avoided. That data should get transferred to the server. for the processing. So node itself can do a multi-hop communications and transfer their data to the next gateway. So when you design any network of an IoT, you must always keep an option for the multi-hop communication. Always keep a backup gateways or backup devices. Otherwise, your network may get collapse at any point of time and you cannot get a responsive actions. So you should always design in terms of managing your network over in the downtime. So all devices are not going to die at the same time. Some devices may get converted into a certain type of devices, so they can act as a gateway or they can act as a multi-hop data communication module or a node. So in wireless communications, you also have other options of multi-hopping. So you can divide your frequencies or individual channels you can use for communications. So these are additional features in detail. If you can start working with a device or wireless devices, you can understand what is channel, which channel can be used for communication. Can we use all channel for communications? So we have a type of communication, broadcast or point-to-point communications. Everything is basically helping us to minimize the latencies. Depending on your requirements, you can make a switch. Likewise, we have a throughput. So that is another important measure of network performance. If you want to have a certain responsive actions corresponding to your processing, you can modify your topologies. So virtualization, as I discussed, in network also you can do virtualization. You can create a virtual switches. So with virtualization, you can also ensure the security, because physical adapter, anyone can target various type of attacks. But virtual adapters, you can change at any point of time. You can assign a different IP set. You can also do a VPN, virtual private network, you can create with virtualization. So these are the few mechanisms through which you can protect your network also. You can also translate the topology. If you can see wired communication network, we have a fixed topology. We cannot make any change into that. If we can make any change, we have to completely rearrange all the devices. That is costlier. But through virtualizations, we can rearrange our network into any set. We can look around what is the optimal way of data communications with a lower latency, higher throughput. We can arrange our network. So dynamic network can only be possible if we can make use of virtualizations in the network also. So various type of topologies, you can translate your network. You can take one gateway at the middle and all the nodes at the other end. You can create some routers in before the gateways. You can create some coordinator nodes before the gateways. So you can arrange into various type of topologies, hybrid topologies or predefined topologies to gain better throughput from the system. Fault tolerant, so your network should be fault tolerant. It should not get affected. Let's say if one device getting inactive in the network, in that case, you are unable to transfer your data. Let's say if you have just kept one particular network and in that network, one device is not responsive. In that case, the whole network is going to get affected with this. So virtualization, as I said, virtualizations can simply isolate a device from the network. So you can easily manage the fault inside a device. If one device is not responsive, you can redirect your communications with another node by changing an IP set, by changing into the routing table, which is basically the way through which you can also manage your network properly without any fault. So you can manage your faults by detecting whether ping is there in a communication network. If you detect any faults, you can isolate the node from the network, because that node may be malicious. Somebody is going to hijack that node and penetrate into the network. Or you can restore the faulty node by remotely logging to the device, rebooting. So various such options always be there. So most of the enterprise or various industries, they always caps one backup servers or 5 to 6 backup servers. If one fails, then other can take over it. So kind of fault tolerant mechanisms they have in their network. So IoT is also a kind of global network of devices. If one device fails, will not affect the performance of the whole automations. Scalability and range. So what is the important factor here? Scalability means, let's say if you are interested to scale your network. Initially, it was designed with 1,000 devices. Suddenly, you have just expanded to 2,000 devices. So your network planning should be in such a way that it should not affect your existing network. Your plan should be according to the expansion. In future, if it is going to be expand, it is not going to change any of the infrastructure requirements. So scalability is one of the important factors which is basically deciding by taking into the account for the future. So how you can scale your network? That automatically adjusts. So dynamic and self-adaptability, which I have discussed earlier, is basically the feature which basically enable a network to be optimal in all cases. Either it is a scalable network or a smaller network. Either any change in the network or devices are failed in the network, still it can maintain that particular requirement. So that you can enable it with the feature of dynamic and self-adaptability, self-configurability. So topology translations, you can do it if we have 1,000 device network, which gives us the every device a bandwidth of 1 Mbps. When 2,000 devices are there, still you want to have 1 Mbps. You either can add one more router into it, or one more gateway into it, or you can have another mechanism of traffic shaping to adapt that particular change in the network. It should not basically change complete system. A few modifications automatically self-organizing network can do in order to have this particular feature. So these days, if you can look at SDN is very, very popular technique through which we can centralize all our decision making, and independently we are giving the data plane for communication. So all the decision makings are centralized in SDN. So self-organizing network is one of the way, another is SDN. So SDN is basically another way of optimizing your network requirement. Either it is a scalable, non-scalable, or expanding or dynamically changing. You can adapt according to the requirements. So range and number of hops, basically it is also related to the coverage. It is also related to the performance. If you are interested to have the latency as minimum as, then you should limit your communication hops, how many intermediate devices you can use in order to exchange your data between a gateway or a device. So these are the specific features related to the network, which I have identified in my development for a certain applications, but even you can expand it even more than that. There are many such challenges which needs to be addressed in the networking domain. These are the few of them which I have also discussed. Next important one is the information security, which is not taken up seriously from the long time. If we can look at the IoT is a device of the constraint network, a network of constrained devices, they can be easily compromised from a various type of attacks. So sometimes we use remote login with a telnet protocol. So many of you have used telnet. So when you use a telnet protocol for remote access over a device, you are actually sending a plain text information. Your information is never be encrypted form. It is a plain text. If you are putting a username and password for logging over this remote device, you are sending a plain text of username and password. If somebody is capturing your packet, he can read out your username and password very easily. So there are SSH, there are various VPN tunneling mechanisms are there, various access control limits you can introduce. So usually we have various system in place for managing confidentiality, authenticity, and authentications. But most of the systems are designed for the bigger systems. They will not have certain limitations. So we must require certain mechanisms in order to safeguard our device network from the public network attacks, because public network is a network of various type of standard devices. So we can get an attack from different type of network sources. We must ensure all these important information security related concept. How we can ensure confidentiality? We should have some lightweight encryption mechanisms to hide our data. We should use VPN and tunneling in order to protect our data from in a public network. So various such security mechanisms are required, which we can actually use for saving our device network from the external attacks. So before you can deploy your network of devices, you should also ensure there should be a certain penetration test you can apply over the network and look out whether device's network is compromisable or not. IoT gateway capabilities. So very important part of the network design is a gateway, because most of our data gathered at the gateway. So we either go to the cloud server beyond our gateway to the public network, or we can process it at the gateway. So gateway should be capable enough for a multi-interface communications. And it should also have processing capabilities. It can process your data. It can store temporarily your data. It also ensures security over the data. So if you are operating with a constrained devices, so individual node cannot ensure the security. It cannot store the data. You can do all such requirement at the gateway. So usually gateway should have rich functionalities. So gateway can also be a computer, or it can also be a router, or it can also be your individual high-end IoT device, which can do many such activities altogether. It also supports multi-interface for communications, not only just the internet interfaces. It should also have Wi-Fi. It should also have IPv version 4, version 6. That is why if you can look at the different devices, they have a different gateways also. If you can go with the LoRa devices, LoRa gateway is available. Okay, likewise, every device type will have a different type of gateways. And along with the gateway, you can get different devices, which is available in the market. But the gateway is not nothing. It's just a particular computing system where you can have a processing, storage, and various type of features through which you can safeguard your data, process your data, make any decision making at the data, at the node itself. Now let's come to the logical design. What is logical design of an IoT? So basically, as I said, device can be integrated to informational network. If you are interested to perceive some of the informations from the network or worldwide or public networks, you still have an option. Semantic web technologies are offering such a way through which you can make the worldwide data source as a machine understandable data, which machine can take and make use of it for its decision making. So when we talk about an IoT, a global network of an IoT devices, a doctor from America can operate a patient in India through just using an IoT communications, or through a robotic arm, which he can real time he can monitor it from the America. So such kind of communication networks, we can establish it. Certain informations which we want to process it and make it more useful. Okay, Like Chat GPT these days are very popular amongst many people, but it is not yet connected with internet. Once it gets connected with internet, it can perceive more information. It can give you more detailed data or understanding. So that is what semantic web technologies is basically helping to have this kind of features through which you can collect the different data sources and convert it into a machine understandable so that machine to machine communications can be possible. So there are various challenges in this also. It is not a well studied problem in the IoT domain, but still it has a greater advantages in future for AI based systems or for the data which you want to process it for certain analytics. So the problem is that vastness data is so huge, we cannot collect any data from any random sources. So recently, few of the problem happened with Alexa. Alexa gave the challenges. So it has just acquired some data from internet and given as a challenge, which is actually inappropriate for a certain age group. So such kind of vague data you can get it just because of the World Wide Web has a lot of data which you cannot separate it. Which one is genuine, which one is fake. Vagueness is too much, uncertainty is too high, inconsistency is there, and deceit is there. So you cannot have a proper representation of your data. That is why most of the automation industries, those who are looking at the data source, like Google is sitting on the data, a lot of the data Google collects from their devices, either Android devices, smart TVs, Apple cars, everywhere they have their own system. They are collecting a lot more data. So they have their own intelligent applications in using such standardized data. But worldwide data, we cannot trust it on the vast amount of data. So how we can use this global data for possible predictions or proper representations of our analysis. So this is all about the logical design, where you can look around the technologies which can make use of the informational network data in a more and more appropriate manner to share among. Besides that, in logical designs, you have various protocols through which you can exchange your data, like HTTP is there, MQTT is there, and distributed data processing is there, DDS is there, constraint AP there. So these are just a protocol to exchange your data between your device to your application where you want to visualize your data, where you want to process your data. These are the protocol standard which can carry your data in a different format. So they have different type of communication models also. Some of them use the public publisher subscriber, some of them use a client server, kind of various. So XMPP is one amongst that, which is widely used in WhatsApp communication. Various messengers are working with the XMPP protocol. So it's a real-time protocol which can give you the real-time information about the status. Some of these web development framework which I have used in some of the IoT design. So I have designed some of the applications where I have collected the data from physical devices, measure the data, process the data, and visualize the data. So this is one of the applications where we have used IoT devices for home energy management system. So we wanted to operate some of the appliances based on the occupancy. If person is there in the house, we can operate a light. We can also sense the environmental light. What are the facings of the windows? Based on that, we have created a home energy management system. And we have used basically a Wi-Fi here to locate a target without putting any device over the target. So target is just moving inside a house. We have our gateway, basically a router in a house for accessing internet. That itself can detect a person where he is located inside the house. So one additional device we required, that is Node MCU we have used, which has onboard Wi-Fi, which will send ICMP messages Through that ping, we are going to get a channel state informations, which basically gathers the environmental dynamics. So if any moving object inside a house, we can track with the CSI data. So it is working with the non-line of sight as well as a line of sight. Through wall scenario, we can also detect a person who is walking behind the wall. So we already published some of the research work with this. If you are interested, you can read out some articles. One more work we are doing with the DST funded project. In this, we are making a freshwater aquaculture for pearl farming. Here we also use some of the devices, some of the sensor. The base requirement here is to monitor the water quality, adjust the water quality. Basically, we have designed a RAS system, recirculative aquaculture system, where we have used some actuators and some of the sensors, which basically monitors the water parameters. If there is any fluctuation in the water parameters, we recirculate the water. So we have biofilters into this. Biofilters, filtered water we will be again dumping into the tank. So we used this freshwater pearl farming. We use some food also there. So we have used green algae as a food. When we add a green algae, at the night time, it is going to consume the dissolved oxygen from the water. So we operated an aerator and balanced the dissolved oxygen requirement. And pH change, so everything is time dependent. From morning to night, there is a lot of fluctuation in the water parameter. And to make them optimal according to the requirement, we are running it through a sensor and actuator systems. We also made a dashboard where we can visualize all the data related to our temperature, pH, and TDS. So these are the few of the work which we have implemented with an IoT device to complete stack of development, bottom to top. We also kept some fog node into this at the gateway, which will basically process our data when internet availability is not there. So with this, I'll complete this session. If anyone has any doubt, any queries, they can please post it through a comment or they can directly ask. Thank you.
If any student want to ask any question with this topic,
Hello.
feel free to ask that.
Yes.
Hello, am I audible, sir?
Yeah, you are audible.
First of all, good afternoon, Dr. Munesh Jain, sir.
Yes, sir. Yes,
Ishwarlal Rathod, Assistant Professor in Symbiosis University of Applied Sciences in Indore, attending the workshop at IIST Indore.
Oh, great.
Sir, dear sir, first of all, I would like to thank you so much for such a wonderful informative session gave us on design issue challenges. And secondly, I would like to ask, we have some hands-on sessions on the covered portion, because in a fantastic or fabulous manner, you have covered all the things. So in future, can we have some session, hands-on session or some example?
Sure. Actually, I'm planning to have one hands-on because I have a lot more devices, lot of things are there, but I have not yet arranged any workshop till date. But I'll definitely have some practical hands-on.
Great,
so some
great.
Devices, I'll show you how to connect it, how to receive, to process it. Definitely, we can have it.
Because I am as a assistant professor, we can understand it's a too bulky content we are digesting today. If hands-on session are their own, then that will definitely help us. If I am correct, if I am wrong, please correct me.
Yeah, it's correct. Actually, I was also planning to have some work hands-on, but since time limitation was not enough because
right, sir.
Yeah, it was intimated me before 2 days before that I have to take a session, so I was not able to arrange any practical hands-on. But definitely in future we will be organizing some workshop.
Right.
And gives definitely the hands-on.
Thank you so much, sir. Thank you so much. Great content, great content, sir. Great content.
Yeah, thank you, sir.
Thank you so much. Have a good day, sir.
Yeah, thank you.
Okay, good afternoon, sir. This is Dr. Krishna from Sikkim Manipal University.
Yeah, Krishna.
Sir, I have one question regarding layered architecture.
Yeah.
As you have shown that IoT devices also have divided the things on different layers.
Correct.
Now, since these devices are very resource constrained, so is that that all layered have been divided on different, like some part has been given to sensors, some part has been given to gateways, some part has been given to like on the servers part to do the analysis. Is it divided in that way, or the IoT devices has to cover all the layer? So I just wanted to get some insight on that, sir.
Yeah, actually, if you can look at the device perspective, if device can operate with an IP, then it can operate at the network layer, physical layer, data link layer. Okay, if you are working with a personal area network devices, which is non-IP based, they can work on a physical layer and data link. Gateway is a device which can operate on all the layers, even from the physical layer to the application layer. Because every place we require a gateway. In application data conversion, we require a gateway. In physical device, we have different standard of devices, we require a gateway. So gateway can operate on the all layer of the OSI reference model. But here the naming of the layers are different. In physical layer, we normally use in our OSI reference model. But in IoT, we use perception layer. Perception layers is the layer where we will receive the informations from the set of devices and sensors. Same way we process our data in a data link layer if we use a certain standard of devices. As I said, non-IP devices, still we can create a network without any IP. That is what ZigBee can create a network, Z-Wave can create a network. Okay, so still we have a concept of layering structure depending on type of devices, depending on type of applications. So if you are working with a cloud-based or web-based applications, definitely we can go up to the application layer. So our dashboard is an application layer where we can have a presentation layer kind of encryptions and compression techniques, session layer. So these are the three layers are part of the one application. Okay, so transport and IP is basically a protocol that we are using for a reliable and unreliable communication, UDP, TCP. So depending on the protocol set, if we are using constraint AP, then we are using UDP. When we are using MQTT, we are using TCP. So all layers are there in the IoT also. Depending on type, what type of standard devices we are using. If network is involved into this in a device, like let's say if an embedded device with a network interface, then you can operate it with all layers of OSI reference model. Okay.
Okay. Thank you, sir. Thank you for giving a great information. So just to have a small question once again. Is it possible that if I am controlling only the gateway, the interoperability can be achieved with that? Maybe I am.
Interoperability issue is not just limited to one specific place. It is entirely available on every place. Either you are talking about applications, either you are talking about the databases. These cases are only come when you will use a different set of devices. Homogeneous networks, you may not face such problem. But IoT is what? Heterogeneous network of devices. So interoperability issue is prominent and we need to address it with certain gateways. Gateway is not a physical device. It is like a software also, or you can also have hardware. Anyway, you can create a gateway. Okay, so it is software based. If you are working with a data exchange or some certain kind of formatting, you can create some small Python program that can also act as a gateway for your protocol conversion. Okay, so interoperability issue is common.
Thank you, sir. Thank you.
Thank you. Yeah, anyone else who has any doubt, then they can ask. so if no further doubts are there, then I can close this session. Thank you for patient for listening, all the participants. Thank you very much. Yeah.
Good evening, sir.
Yeah, good evening.
Sir, due to some academic important work, Dr. Neelam Dayal ma'am not present yet. So I want to say a few words for your thanks. Can I continue?
Yeah, sure. Please go ahead.
Okay. I would like to grateful thanks to Dr. Munish Singh for their explanation of the topic of physical data link layer of IoT. He explained the topic in a wonderful manner with a content of slides like IoT development stack, technology roadmap of IoT, network design of IoT, etc. And next, I would like to thank to all the center instructor for their physical presence, and also thanks to all senior faculty of this program and participants, students of this programs. So overall, thanks to all. Thank you, sir.
Yeah, thank you. So can I leave the session?
Yes, sir.
Yeah, okay. Thank you very much.